Hello everyone, welcome back to my video series about developing the Iron Ball game with Unity and C#. If you missed the kickoff video, I would recommend to watch that one first because it will give you a 5-minute short idea of what this is all about. In today's video I want to walk you through the development of the prototype. Yes, I made it, I created a simple prototype. At the beginning I'm going to show you the fully working prototype. Next, in the main part, I focus on explaining the physics of the game and how I build the separate parts together. This also includes a short excursion on the subject of the FixedUpdate function and the difference between scene view and game view. I hope especially this piece is useful knowledge for everyone who wants to use physics in Unity. It made me the most headaches and I'm happy to be able to share my unexpected findings here with you. Finally, in the end, I show you how I adjusted the overall behavior of the ball to make it roll more like a little iron ball than a slow bouncing bowling ball. Sounds interesting? Let's go! When developing a prototype, you should closely look at the things you really need to make your game work. Remember, I don't want to over-engineer. So let's have a look at the analog game again and see what we need. The game has a bottom, a corner, a transparent top, and all of that to cover the balls inside the game. So I used 6 game objects to lay the foundation. There are 4 cubes that create the border and 2 planes, one of which is the bottom and the other one is the transparent top. I arranged them to look like the board I need. Yes, I noticed it is a square instead of round, but it doesn't matter, it's just for testing and I can decide for another form later. I also created another game object which is a sphere to represent a ball. All game objects have materials with different colors. This makes it easier for me to separate them during development and testing, and it already gives me an idea of what they could look like in the end. Finally, I bundled all game objects that make up the board in a hierarchy. Speaking Unity, I used the hierarchy to make the borders and the top childs of the parent object. This allows me to move the bottom plane with a script and the whole board will move with it when the player rotates it. Let's see how it looks when I start the game. You can move the board and the ball moves within the board, physically correct without falling off the board. I only added 4 directions so far, controlled by keyboard keys, but that's enough for now to see if the behavior is roughly what I expect, and it works. As you can see, something very important is still missing. The board has not have any holes yet. Currently, the bottom of the game is just a simple flat plane. The reason for that is that I did not want to waste time on designing a plane with holes out of multiple game objects or in Blender. I already know that I will be able to do this later. In order to test the actual game mechanic anyway, I decided to implement some kind of detector instead. This detector represents the position of a single hole for now and will later be invisible. So I added a capsule and made it react to trigger events. It changes its color to green as soon as the ball enters it. This proves the game will be able to react with some kind of win condition state as soon as the ball enters a specific location on the board. Now I have everything I need. Looks easy, was easy to build. Only managing the physics was a bit tricky and this is what I want to show you next. To build the prototype, I started with a simple plane and a sphere and positioned the sphere right over the plane. When you start, you see nothing happens. This is because both game objects have no ability to react on physics. To make the ball behave like a ball, I added a Rigidbody component to the sphere and enabled the checkbox Use Gravity. You see, the ball now falls and stops on top of the plane. This happens through colliders. Both game objects already have colliders when we create them. If one collider hits another, something happens. In this case, the collider of the plane stops the sphere from falling down. You would assume that this is everything we need, right? Because if we rotate the plane, the ball should roll. Let's test. Very much not like expected. This happened because the plane needs to have a rigid body as well to simulate physics correctly. Oops, Forgetting to turn off gravity for the plane. Here it is again. The ball falls through. Why is that? Although the plane already has a collider which successfully stopped the ball previously, now with the rigid body component on it, it behaves like a physical object and we must declare how it would behave. I do this by enabling the isKinematic checkbox for the plane. And again, now it stops correctly, and when we rotate the plane, the ball behaves as expected. My learning here was, if you want to create a physical object that you don't control and that is only dependent on outside input forces, then you must leave the checkbox isKinematic blank, like for our ball. It should only react physically correct and we never control it directly. On the other hand, if you want to create an object which is able to react with other physical objects but is under your direct control, then you need to make it isKinematic. Now let's have a closer look to our plane and ball. Although the ball rolls correctly now, something very strange happens when I rotate the plane quickly. The ball suddenly falls or clips through the plane. I did some research and found that the root cause for such behavior is the collision detection parameter on the rigid body components. Fast-moving objects can sometimes clip through other ones. In order to prevent this, I changed it for the fast-moving object, our plane, to continuous and leave the ball with discrete. You see, probably a bit better, but not very much. I did more research and found that all physical movement must be scripted not within the regular update function, but in the FixedUpdate function to work correctly, which makes much sense because physical behavior is very sensitive and should not be out of sync. So when I learned this, I thought, okay, well, cool, I will use it info for later when programming the game, but for now, why should I write code when I can control the movement via scene view? And here comes the thing I missed or overlooked, what you want to call it. If you do translations or rotations in scene view, even during runtime, Unity will always handle this change like it would happen in a regular update function. So what you really must do is testing your movement of physical bodies in code during runtime and not via the scene view. Let me show you the difference on two examples to make it clear. Here is a plane, a ball and a cube. The cube and the sphere have rigid bodies. The cube is kinematic, the sphere not, but the sphere has gravity. Pretty much the same I plan to use for my game. If you now go to scene view and move the cube really fast against the sphere, it clips through. Now see what happens when I apply a script to the cube. This is the code. Nothing special other than accelerating the cube within the FixedUpdate function. Let's start the game again and see the difference. The cube punches the sphere away like it should be. And the second example is my game. You have already seen what happens when I rotate the plane in scene view. Now let's add a script to the plane that controls the rotation in the FixedUpdate function. And ta-da! It works. It took me hours of investigation to recognize this simple difference. Maybe it was too obvious. If you ever also stumbled on this behavior, feel very welcome. I hope this bit of extra information will help you all when playing around with physics in Unity. Let's head over to the last chapter, adjusting the behavior of the ball. You see, it rolls like it should do. It does not clip through walls, but it is very slow and very bouncy, by the way. If I remove the top, you can see what I mean. Boing! In order to make the ball behave more like a little iron ball, I added a continuous force from the top to it via script. This reduces the bounciness. In addition, I played around with the mass of the ball and its radius, which means the scale of the sphere, in order to achieve a velocity behavior that looks correct. So now For me, it does. If you have also experience with marble-like games or tuning the behavior of a ball, maybe even with other parameters, I would be happy to hear about it. Just write me in the comments how you did it. Okay, that's it for today's video. In the next video, I will show you the beginning of the real development of the game. I already decided how to move on with the video series. You can expect different videos for each aspect of the development process. This means I will make one about the board, the sound, the menu, and so on. This hopefully gives you some more insights, and there is also the little Blender tutorial on the road, which I teased in the first video. Anyways, there's a lot to be done. Thank you for watching, and I hope you had fun and maybe even learned something. See you in the next video.